So in lesson 1 we learned about basic trigonometry, SOHCAHTOA, which we use in right angled triangles, but we can actually also use trigonometry to find the lengths of missing sides and missing angles in triangles that are not right angled, and that's what this involves. So using trigonometry to find missing sides or missing angles, or missing angles in non-right angled triangles. Now this requires new formulas, so we can't use SOHCAHTOA anymore. We use the sine rule and cosine rule. And we have to label up our triangles slightly differently again, so must label our triangles. So an example of a non-right angled triangle might be something like that. So there you can see that none of these angles are right angled. Now to label them up, you tend to pick A, B, C just because the formulas are written using the letters A, B and C. However, you can actually use any letters. But I'm just going to go with A, B and C. So the angles are capitals and the sides are going to be lowercase. And we do those opposite the angle. So if this is the angle A, it's the side opposite that angle that has small a. If there is angle B, then the side opposite will be small b. And there is angle C, so the side opposite will be small c. So that's how you would label up your triangles for further trigonometry, for the sine rule or the cosine rule. Now let's have a look at the formulas and try some examples. So first of all, we'll look at the sine rule. So it's A over sine A equal to B over sine B equal to C over sine C. And that corresponds to your angles A, B and C, and your sides small a, small b and small c that were on that triangle on the last page. Now you can see that there are two equal signs in that equation. Now we can't solve something with two equal signs, so at any one time when you're trying to solve this using the equation, you're only going to ever use two parts. So you might use A and you might use B, or you might use C with B, but you wouldn't use all three of them together. So let me just rub out all these little dots. Okay, so let's have a look at using this formula. So example 1, we're going to look for a missing side. And it says calculate side x. So we're trying to find the length of the side x, and in order to do that we're going to label up our triangle with angles A, B and C and side A, B and C. What I'm going to do is I'm just going to make this one A, this one B and this one C, but you could have chose any combination there, doesn't really matter. Now this will be small side A because it's opposite our angle. Opposite side angle A would be small b, and opposite angle C would be small c. Now you should always start by writing out your formula again, so I'm going to write that formula and then I'm going to substitute into the formula. So what information do we have? Well, we know information about side A, although we don't have a number, we know that it's called x. So we'll replace that with x. Then we have an angle for angle A, so that will be sine 95. B we don't have any information for, so we'll just leave that blank for a second. And then for C, we know that the side is 4, and we know that our angle is 40. So really we're going to disregard B. So B is the part of the equation that we are not using in this case. So we're just using the A and the C part of the equation this time. So we will write that. I will just move over a little bit and write that out again. 95 equal to 4 over sine 40. Now we want to get x by itself. We're dividing by sine 95 here, so we need to multiply up to get rid of it. So x is equal to 4 over sine 40 times sine 95. And what we end up with then, when we do that calculation on in our calculators, we end up with 4.40 centimetres to 2 decimal places in this case. And again, if the question doesn't tell you what to round to, you just make a sensible choice there. So we've gone for 2 decimal places there. So that's an example of finding a missing side. We can use this same formula to find an example of a missing angle. So that will be either your sine A, your sine B, or your sine C part of the equation that we are trying to isolate and get by itself this time. So let's have a look at that example. Example 2. Calculate angle x. Okay, so you can see that we have information about 2 angles and 2 sides here. Let's label them up A, B and C. I'm just going to go for the same again. So A, B and C. So this makes that small a, that would be small b, and this would be small c when we label up our sides. When we go back to our formula, and we start to sub in what we have. So we don't have any information about side A, we don't even have a letter, and we don't have any information about the angle sine for angle A. So basically we are not using the first part of the equation. So we'll just score that out now and start to sub in the information for B and C. So the length of side B is 9 and the angle is 75. So we've got 9 over sine 75 is equal to 4. So the length of C is 4. And we don't know our angle, but we've been given the letter x. So I'll change that to sine x. Now we need to rearrange here so that we have, first of all, have sine x by itself, and then eventually we'll try and calculate x. The easiest thing I would say to do here is to do something called cross multiplication. So we multiply the bottom of this fraction with the top of that fraction, and the bottom of this fraction with the top of that fraction. So we end up with 9 times sine x equal to 4 times sine 75. That's cross multiplication. And finally, to get sine x by itself, we move our 9. It's a multiplication on the left hand side here, so we divide by 9 on the right. So sine x equal to 4 times sine 75 divided by 9. And we end up with sine x equal to 0.4293 when we work out the right hand side in our calculator. Now, just like our basic trigonometry in lesson 1, when we get to this stage, we have sine x equal to something. We want to get x equal to the final answer, so we have to take the inverse sine. So we're going for inverse sine again, which is sine to the minus 1. And remember, that was the shift followed by the sign button on the calculator that gave us that. So we would have x is equal to sine to the minus 1 of 0.4293, which gives us 25.4 degrees to 1 decimal place. Before I move on to the cosine rule, I'm going to have a look at a special example of the sine rule and what can occur. So if we have a look at this question here, okay, so we can see it's the sine rule. We're trying to find an angle, so it says calculate angle x. So let's start going with that. So we'll label up our triangle first of all. So I'll just call that A, call that B, and we'll call that C. So this is side A, side B, and side C. If we write our formula, and we start to substitute into our formula, we have 80 over sine 20 equal to 110 over sine x, because we're trying to find angle B, and then we don't need C, we have no values for C. Now let's do our cross multiplication like the previous example to solve for x. So we'd have 80 times sine x equal to 110 times sine 20, dividing by 80, we end up with sine x equal to 0.4703, and we need to take inverse sine again here. So inverse sine. So we've got x is equal to sine to the minus 1 of 0.4703, which works out as 28.05 degrees. Now you might be saying to yourself, how is this any different from the previous example that we looked at? Well, if we look at the graph, our formula is telling us that the angle is 28 degrees, but if you have a look at the picture, this angle here is clearly bigger than 28 degrees. So we can see that this angle must be greater than 90 degrees. It looks almost like it's a 90 degree angle, but it's a bit bigger than a 90 degree angle. And we call that an obtuse angle. So our angle x is greater than 90 degrees. So that's called an obtuse angle. So the answer cannot be 28 degrees. So what do we do in this case? Well, all we do, it's very straightforward. We say to find x, we do 180 degrees minus the angle that we were given from our calculation. So we take away 28.05 and we end up with an angle side of 151.95 degrees. So that is the size of angle x. It's not 28 degrees. So when we are working with the sine rule, we have to be careful when we're calculating an angle, because sometimes our angle is obtuse and therefore the answer the calculator gives us is not the correct answer. We have to take that away from 180 to find our final answer. And the way how you would know that is you have to look at the diagram to know whether this extra step is needed. We look at the diagram given in the question. If the angle is obtuse, we need this step. And that formula has two forms. So for a missing side, you would use this form, a squared equal to b squared plus c squared minus 2bc cos a. And for a missing angle, you use this form here, which is cos a equal to b squared plus c squared minus a squared over 2ac. Now they're basically the same formula, they've just been rearranged. So this top formula has been rearranged to give the second formula. The top one you're trying to find a, the bottom one you're trying to find angle a, so it's cos a. So we use these two formulas to again find missing sides and missing angles, and we'll have a look at some of those now. So example 3, calculate angle x. So we're going to have a look at finding an angle first of all here. Right, so again we need to label up our triangle, so angle A, B and C. Now you can pick, like the sine rule, you can put A, B and C anywhere you like, but it would mean that you might have to rearrange your equation to be able to do that. So it might be beneficial to make your angle of interest A, to always make your angle of interest A. So I'll just say a little hint, stroke tip. Always make angle to be calculated or given in the equation, given in the question A. Okay, so always make angle to be calculated or given in the question A. So in other words, we'll say that that is A, and then it doesn't really matter about the other two angles as long as we've made that A. So that makes that side A, that side B and that side C. So because we're trying to calculate an angle in this case, we are using our second formula, so it would be cos A is equal to b squared plus c squared minus a squared over 2bc. And now we substitute in our values. So cos A is equal to 6.9 squared plus 4.2 squared minus 4 squared all over 2 times 6.9 times 4.2. And you can do that all in one calculation on the calculator if you want, although I would recommend doing the top line, pressing equals, and then having brackets round the bottom to work out the bottom line that you're dividing by. When we calculate that, we end up with 0.8497. And again, similar to the sine rule and your basic trigonometry, we must take the inverse here. So we need inverse cos this time. So that would be cos to the minus 1. We press shift on our calculator, followed by the cos button this time. So A would be cos to the minus 1 of 0.8497. So A is 31.8 degrees, or seeing as it was actually x, we could call it x is equal to 31.8 degrees to one decimal place. Okay, now we will have a look at using the cosine rule to find a missing side. Okay, so we want to find the length of x, and we need to label up our triangle again. So I said previously that with the cosine rule it is important that we label the correct angle A. So in this case we've been given the angle here of 35, so that will be our A. And then it doesn't matter about the other two angles, so we can call them B and C. Now we label up our sides, so this would be side A, side B and side C. Because we're looking for a missing side, we're going to use our other version of the cosine rule. So it's a squared is equal to b squared plus c squared minus 2bc cos A. And we shall substitute in the values that we know. So side A is x, so it's x squared is equal to 7 squared plus 3 squared minus 2 times 7 times 3 times the cos of 35. I've put brackets around that because sometimes when we put the cos of our angle into the calculator, we end up with a negative value, which would then ultimately change this negative sign to a positive. So if you put brackets around this part here, that will make sure that you have the right value once you put that through the calculator. So x squared, once we put that all through the calculator, comes out as 23.5956. Obviously we're not looking for x squared, we're looking for x, so we have to take the square root. The opposite of a square is the square root. So we take the square root of 23.5956 and we end up with 4.86 centimetres to 2 decimal places. So that is the cosine rule using finding a missing angle. So we used our two different formulas, well basically the same formula but in two different forms, to either find a side or an angle. Important here is to label up the correct angle as A. So that's the angle that you're either given a value for, like in this case here, or in the last example it was our x value. That's what we were trying to calculate. So we called that A and then we labelled up everything else from there. A summary. How do we know when we use the sine rule and how do we know when to use the cosine rule? This is an area that a lot of people get confused about, so I'm just going to give you some rules. So for the sine rule, this involves two sides and two angles. Okay, so one of those will be unknown, so it could be that you have two values for two angles. So you're given the value for two angles, but you only have one side, and you're trying to calculate the other side. Or you're given the value for two sides, and you're trying to calculate one angle because you know one angle and you're trying to find the other. But overall, this calculation will have two sides and two angles. The cosine rule is different. It involves one angle and three sides. So all three sides of the calculation are always involved in this formula. Now that might mean that you know two sides and an angle and you're trying to find the third side, or you know all three sides and you're trying to find the angle, which will be called x or some sort of letter, and that's what you're trying to find. So to tell the difference between the sine rule and the cosine rule, you look at how many sides you know basically. So it's two sides for cosine rule and two sides for the sine rule and three sides for the cosine rule.